So after we have seen the application of differentiation in kinematics, we are now moving on to chapter 16.2, application of integration in kinematics. These two topics are very closely linked. So we have learned that for displacement, we denote it by S. For our velocity, we denote it by V, which is differentiate the displacement with respect to time. Then we have our acceleration, denoted by A, which is dv over dt, differentiating velocity with respect to time, or we can say as d2s over dt squared. So we can work backwards from acceleration to get our velocity by integrating with respect to t. Similarly, from velocity we can get our displacement by integrating with respect to t. So in summary, S will be integrating velocity with respect to t. Velocity integrate acceleration with respect to t. So if you want to get to our displacement from our acceleration, we will need to integrate it once, then integrate it another time. So let us try practice now 5, and I'll go through it with you. Practice now 5. Take some time, pause the video, read the question. A particle P moves in a straight line. Velocity is given by 2 minus 2t plus 4t squared. So this is our velocity. And I know that if I differentiate this, I will get the acceleration function. If I integrate this, I will get the displacement function. So this is velocity after passing O, our reference point, otherwise known as the origin, after t seconds. So now in part 1, we require the displacement of the particle P from O. So we want the displacement, which is given by integral of velocity 2 minus 2t plus 4t squared with respect to t. So this is where our basics of integration comes back. 2t minus 2t over 2 with a square on top plus 4t cubed over 3. But this is not the end of the integration yet. We still need to plus c. This c over here at the moment is a constant that we do not know its value. Okay? Later on, we may have a chance to find out depending on further information that they are providing. What we know right now is that the displacement is a function of time. Given any time, any value of time, I should be able to find the displacement. For example, when t is equals to 0, when I sub t equals to 0, I will end up with displacement equals to constant. So this constant has a meaning. It is the initial displacement when t equals to 0. That is the meaning behind it. Okay? So let's carry on with the question. So since the question tells us that t is the time in seconds after passing O, the origin, the reference point, we know that this value of c in this case is going to be equal to 0. When time equals to 0, the displacement is 0. This only happens when c itself is equal to 0. So we can write down when time equals to 0, S is supposed to be equal to 0, therefore c is equal to 0. So in summary, our displacement will look like this: 2t minus t squared plus 4 over 3 t cubed. Part 2, the distance of P from O when time equals to 3. To find the distance of P from O, it is just another way of saying displacement. They are not saying total distance traveled or anything like that. They are talking about the displacement of P from O when time equals to 3. So let us substitute when t equals to 3, s will now be 2 times of 3 minus 3 square plus 4 over 3 of 3 cubed. This will now result in 33 meters. And this is positive, which means that it is in a positive direction, whichever it is. If it is defined as to the right, then it is 33 meters to the right. If positive is defined to the left, then it is 33 meters to the left, depending on the question. But since they didn't say it, we will just leave it as positive 33. So now the distance from O is 33 meters. Okay, earlier on I mentioned that distance of P from O is simply displacement. I take that back, that is incorrect. Distance of P from O refers to the scalar value. So in this case, I am lucky because the displacement happens to be positive. So the distance of P from O is 33 meters. If it happens that the displacement is calculated to be a negative value, for example, let's say after calculation the value is displacement equals to -5, then the distance in that case will be 5. Okay, so I take that back. Distance of P from O refers to a scalar distance. It is going to be a positive value. We are not looking for displacement here. So next part 3. Total distance traveled by P in the first 6 seconds of its motion. Whenever they are asking for total distance traveled, you have to be very careful to check whether there is any turning point. Because as seen in chapter 16.1, turning points, when a particle turns, the total distance will not be as straightforward as simply the displacement. We will need to break up the journey into the regions before it turns and after it turns. Then we calculate the individual distances traveled in order to find the total distance. So let us check for this question whether there is any turning point. And turning point in this case will refer to its velocity being set to 0. So when v equals to 0, we have 2 minus 2t plus 4t squared equals to 0. Continue working it out. To solve for t, we will arrive at t equals to 1 plus minus square root -7 over 4. Okay? This tells us that we can't square root a negative number, means there is no solution. That means there doesn't exist a time t when velocity is equal to 0. There is no turning point in this case. Okay, so now it is safe to say that since it doesn't do a 180-degree turn, its displacement will therefore be the distance traveled by P in the first 6 seconds of its motion. So let us do a substitution for S when t equals to 6. So when t equals to 6, the displacement will be 2 times of 6 minus 6 squared plus 4 over 3 times 6 cubed, resulting in 264. So total distance traveled is 264 meters. The next question we are going to attempt is practice now 6. It is given that velocity is 2 plus 12 sine half t. The approach is all going to be similar. It's just that now we are going to be dealing with differentiation or integration of trigo functions. So to find the displacement when t equals to pi over 3, take note that we'll be working in radian mode. The displacement is given by integral of 2 plus 12 sine half t with respect to t. resulting in 2t plus, now sine, we copy down the 12, sine half t. When you integrate sine half t, you will get cosine half of t with a negative sign. And now we need to divide this by the differentiation of the angle. So divided by half, and we still need to plus c. So simplifying all this results in 2t minus 24 cosine half t plus c. Okay, so this is our expression for the displacement. We currently have an unknown over here, c. So how do we find out the value of c? Question, they said that t is the time in seconds after leaving the origin, which means that when t equals to 0, our displacement should also be equal to 0. When does this happen? It means that now I have to substitute t equals to 0 whenever I see t in my displacement expression, and I have to set this to be equal to 0. So this will result in 2 times of 0 minus 24 cosine half of 0 plus c must be equal to 0. Okay, 2 times of 0 is nothing. Cosine of 0 is 1. Cosine of 0 is 1. So apparently negative 24 plus c equals to 0. C must therefore be equal to 24. So now our displacement is given by 2t minus 24 cosine half t plus 24. Only when the constant is equals to 24 will I have the situation that displacement is 0 when time equals to 0. So now they are asking for when time equals to pi over 3. Our displacement is now going to be 2 times of pi over 3 minus 24 cosine half pi over 3 plus 24. Put this out and we will get approximately 5.31. And this is in meters. The next part of the question, find the acceleration. So acceleration is dv over dt. Differentiating 2 is 0. Then we're left with 12. Sine, when you differentiate, it becomes cosine of half t. And we still need to multiply this by the differentiation of the angle, resulting in 6 cosine half t. When time is pi over 3, substitute this back in, our acceleration will be 6 cosine pi over 6. Get the value, round it off to become 5.20 in 3SF meters per square second. Now let's move on to part 2 of the question. Find the time at which it attains a speed of 8 meters per second. So this tells us that velocity is 8. So what is the corresponding time? Using the original equation supplied to us, 2 plus 12 sine half t is 8. Solving a trigo equation covered in Sec 3, 12 sine of half t is equals to 6. Sine half t is half. This is a positive value. We will know that it belongs in quadrant 1 and quadrant 2. Half t will therefore be equals to sine inverse half or pi minus sine inverse half. These are our two values of half t. So from here, to find the value of t, we just multiply the values by 2. And this will result in pi over 3. And for the other answer, okay, so these are the two times that we have for when it first attains when it attains a speed of 8. So from these two, which one comes first? That will be pi over 3. So the time will be pi over 3 seconds. Okay, this will be rejected because it comes after time equals to pi over 3. For the final part of the question, acceleration. Acceleration is dv over dt. So differentiate the velocity. We will have 12, sine becomes cosine, half t. Then we multiply this by half. So we will arrive at 6 cosine half t. When t is equals to 1, our acceleration will be 6 cosine of half over here, which after rounding off, we will have 5.27 meters per square second. So for the remaining time for these two periods, please read through work example number 7. Do practice now number 7. Read through work example number 8. Do practice now 8.